Hi everyone, welcome back. Let's write some more Leetcode today. Today we're solving a minimum index of a valid split. So the problem description is quite long, but I'll summarize it. So basically what it's asking is if we can split this array into two separate arrays, and after splitting, can there be one element in both of the array that contains more than half of the elements in that array? And we want to return the minimum index of a valid split. And if we are not able to make that split, then we return -1. So if we look at this example, the first place where we can make that split is at index 2, because if we split here, the number 2 will be 2 out of 3 on the first array on the left side, and on the right side, the value 2 will be 100% of the values. So it's more than half on both arrays after splitting, so we return 2 as the result. So now that we have seen some examples, let's get to how we can solve this problem. So before we get to how we can solve this problem, I'll say that I'll use the Boyer-Moore majority voting algorithm to find out the most frequent element in the array. So if you don't know this algorithm, feel free to look it up, or if you don't feel like it, then you can use a hash map to keep track of the most frequent element, but that would be O of n space. With this algorithm, we don't have to use any extra space. So what we will do is after using the Boyer-Moore algorithm, we will set the majority variable to that element, which is the element that shows up the most. And initially, the left pointer will be set to 0, and the right pointer will be set to the number of instances of the majority element. And the left length will be set to 0 initially, and the right length will be the length of the entire array, because in the beginning, the right length would be the window on the right side, which is entire array. And what we will do is we will move this window over, and every time we move the window over, we want to increase the left length window by 1 and decrease the right length window by 1. And when we move the window over, if the value that is shifted to the left length is part of the majority, then we need to increase the left window by 1 and decrease the right pointer window by 1, because we are losing one of the elements, giving it from the right to the left. And if we want to see that it's a valid split, then we will multiply 2 times left and see if it's greater than left length, and we will also multiply 2 times right and see if it's greater than right length. If both of these satisfy, then we can return the left pointer as our result. If not, then we keep looking all the way to the end, and if we still don't have a valid split, then we return -1. So let's go through this example real quick. So first, we move the window over. The left window is 1. The right window has a length of 3. It's not valid because 2 times 0 is less than 1. So we move over again. Now the left window contains 1, 2. The right window contains 2 of the majority element. The left length is 2. The right length is 2. 2 times 1 is only equal to 2, which means it only has half of it. It's still not the majority, so it's not valid yet. So we move down again. Now the left window has 2 of the majority, and the right window has 1 of the majority element. The left length window is 3. The right length window is 1. 2 times 2 is greater than 3. 2 times 1 is greater than 1. So this is valid. So we can return 2, or the left pointer, as the result. And the time complexity would be O of n, because we need to iterate through this array 1 time. So n would be the number of elements. And the space complexity would be O of 1, because we are not using any extra space. So now let's get to the coding part. So first we will set the majority to 0 and the count to 0. So now I'm going to implement the Boyer-Moore majority algorithm. So for n and nums, if the count is 0, then we will set the majority to n, and then we will increment count by 1. Else, if n happens to be the majority, then we will increment count by 1 also. Otherwise, we would decrement count. So now the left pointer would be 0, and the right pointer would be the number of the instances of majority, so nums.count majority. And the left length will start at 0, and the right length will start at length of nums, because that's the window. Now we will loop through nums for I in range length of nums. If the number happens to be one of the majority element, then we need to shift the left pointer and the right pointer. So left plus 1 and right minus 1. And no matter what, we will always shift the window. So left window will increase by 1. The right window length will decrease by 1. And we want to check if it's valid. So 2 times left is greater than left length. And 2 times right has to be greater than the right length. And if that is the case, then we return I. And if we still don't find a valid split after all the iterations, then we return -1. All right, let's see if it works. Okay, perfect. Hope this was helpful. Thank you all for watching. If you have any other questions or comments, feel free to leave down in the comment section, and I hope to see you all again soon.